You have a 10 kg block is pushed up per inclined plane, making an angle of 30 degree with the horizontal. So let me quickly make the diagram. I think we don't need bottom space. 30 degree would be something like that. So this is 10 kg. And the coefficient of friction is 0.2 kinetic friction. And you have a force of 150 Newton. And moves a distance of along 5 meters. So from point A to point B, this is 5 meters. Then what else? Then we have frictional force. That would be that. Okay, anything else? I think I didn't miss anything. So we have a 10 kg block is pushed up an inclined plane, making an angle of 30 degree with the horizontal. The coefficient of kinetic friction between the block and the plane is 0.2. I wrote that. If the block is pushed with a constant force of 150 Newton parallel to the inclined plane, it moves a distance of 0.5 meters along the inclined plane. Determine the work done by the applied force. Okay. So work by applied force. We can do it with we should be doing with force into displacement. So force is 150, displacement is 5, and it's both are pointing in the same direction. So whatever that is your answer. Please note that we need to write theta is equal to 0 because, okay, all of that carries mark. If when I did correct, so when we correct papers and stuff, teachers, we see this. Whenever I correct my students' book and answer script and stuff like that, I see to that this aspect is written. Everything else is secondary. You need to reason out what is that you're writing and why is that you're writing. Work done by gravitational force. Okay, so work by gravity would look something like this. So you have, I need to write all the, basically this is a free body diagram of the block. And we have frictional force as well. F of k, if you guys want to write, this is your normal force, or I'll write R, and you might get confused with. This would be mg, it would be, I kind of forgot, this would be theta, so this is cos of 30 degree. Again, all this goes back to your very first set of discussion wherein we saw this. Actually, I'll just do a rough diagram quickly. You have this and you have a force pointing downwards. You have a force perpendicular to this. So we need to figure out this force. Since this is 30, this also will be 30 for reasons that we have discussed. So that will be 30, and with this will be mg cos of 30 degree. This is your normal force. Okay, and gravitational force is also there. I forgot. There is a gravitational force as well. This will be mg sine 30 degree. So this is the force that we need as of now. Okay, so force by gravity or work by gravity is equal to force by gravity times of displacement cos of 180 degree. So this is m is how much, guys? As 10 kg. It got displaced by 5 meters if I'm right, and this is -1. So wait, oh my bad. I'm mixing everything up. 10 into 10, mass is 10, this is 10. Sine 30 is 1 by 2. Displacement is 5. And this is minus 1. 1s are 5s are 25, 250 minus 250 Newton. Oh, sorry, this is not force. This is energy. Okay, what else? Oh yeah, this is done, this is done. Work done by the frictional force. So work by frictional force. Same thing again. Frictional force is equal to force of friction. Fk is what I have used over there. Times of S times of cos of 180 degree. So how much is this, guys? Mu k is 0.2 if I'm right. Normal force is mg cos 30 degree. Okay. Displacement is 5 and minus 1. So this is 0.2. M is how much? M is 10. 10 root 3 by 2 into 5 into minus 1. 1s are 0.1s are. This 2 will become 1. And this is 50 root 3 minus 50 root 3. Again, please complete the calculation if need be. If not, as in they're not asked you guys to find after this anything related to this, you can just leave it over here. Okay, then what else? This is done. The net work done on the block, quite simple. So all the things that is acting on the block. Net work. So the net work done by the block is work done by gravity, work done by the force, and work done by frictional force. Since we need this answer, then we need to solve it. Okay, this would be sin 50 cos 0 itself, yeah. So we have 750 minus 250 minus, this is 50 root 3, this is around 86.6 approximately. Okay, so this also I need to do. 750 minus 250 minus, and this is 413.4. That's the net force. Okay. The change in the kinetic energy of the block. So yeah, how do you do it? Change in the kinetic energy. Change in kinetic energy. Hey guys, how do you figure out the change in kinetic energy? As per work energy theorem. So if I happen to find the net force, which I did, this has to be equal to the kinetic energy, and so this would be the answer, so many joules.